I'm going to go over exercise 33 and what you need to do to complete this exercise. So I have here the file that I've prepared, and you can type your answers into this, or you can create your own file if you'd like to. So let's start with, first let's note that we have data that comes from a section called Data for Additional Computational Practice. I've provided you with the Excel and SPSS version of this data. You can also just type it into your own file if you don't have it prepared already for you. I'm going to need to do some calculations for this assignment, so I'm going to look first and see what I need to do. So it wants me to answer some questions about the variance. And to answer question 1, I need to calculate the variance. I won't know if it meets criteria until I know what the variance is. And then number 2 wants me to do frequency distribution. And number 3 wants me to calculate the mean. And number 4 wants the F value and the degrees of freedom. And then number 5 wants me to know if this result is significant. So basically, I need to do some calculations for all of these. So I'm going to go ahead and go to my Excel file, and I'm going to calculate a few things and come back and answer these questions. So what I'm going to calculate is the descriptive statistics. That will give me the variance and also the means for the groups. And then I'm going to go ahead and calculate this frequency distribution and go ahead and run my ANOVA. So I'm going to do those 3 things, the descriptives, the distribution, and the ANOVA test, and that's going to give me the results I need to answer these problems right here. So I'm going to go to my Excel file, and the way I have it set up, I set up 3 tabs just to make it easier for myself, so I'm not trying to do everything on the same page. It would get a little bit cluttered. So I have my descriptives, I have my frequencies, and I've gone ahead and grouped my data into ranges. If you don't have your data grouped like this, you can go ahead and just do that yourself. You can create your own groupings, or you can just use mine and copy it over. So I just figured out some of the ranges for hours worked that made sense and figured out how many were in each of those categories. And then I made a table or a different tab for the ANOVA analysis. In Excel, it likes to have the groups next to each other in separate columns. The way this data is set up is with group 1, group 2, and then group 3. I added these little dividers here just to visually make it easier to see the difference. In Mac, at least for the two-way ANOVA, it wanted the data grouped this way. But in Excel, I need my data grouped like this for it to run properly in an ANOVA. So I set it up just same data, just oriented differently. So let's go ahead and start with the descriptive statistics. I need to know the means for the 3 groups. So I'm going to need to run descriptives for group 1, group 2, and group 3. I'm going to go into the analysis tool pack and do the descriptive statistics for group 1. So remembering what I had in here last, I just was setting this up a minute ago, so it's remembering that. But go ahead and select your data for group 1. Now, if my data was set up like it is on that last tab, I could just do all of them together and it would give me 3 separate charts. Because it's oriented all in one column, that's not going to work. I need to do 3 separate charts. And what I'm going to do is not select the last variable. So my results are going to be a little different from yours, but pretty similar. Just make sure you do select the last variable for group 1. And let me tell it where I want the output to go. And I need to make sure the summary statistics box is checked. That's what's going to give me that chart output. I'll go ahead and click OK. And this is for group 1. Remember, mine will look a little different because I'm not selecting the last variable. And let me do the same thing now for group 2. And again, I'm not going to select the last variable. And I need to change the output range to be over here and click OK. And this is my group 2. And then lastly, I'm going to do this for group 3. and I need to change the output range, otherwise it would overwrite my other chart. So I'm going to say that's a good spot for it and click OK. And this is group 3. I'm just typing these in here to keep myself on track. So remember, I didn't select the last variable for each of the groups, so my results will be a little different, but I have my mean and I have my variance here. I can widen these columns a little bit just to make it a bit easier to read. So there we go. Now I want to do the frequencies, which is going to be that bar chart. And I wanted to show you a little different way to do this. I've showed you how to do it in Excel several times in the previous videos where we had to do this for homework. So now I'm going to show you how to do this using an online calculator. And I'm going to show you using this calculator, which is just easycalculation.com. And I found this by just Googling a frequency distribution calculator or a histogram maker. Now I need to enter in the information here, so I'm going to give it my graph title. I'm going to call it something like hours worked for 3 groups, or something meaningful for my data. This isn't super fantastic title, but just something like that will work for this assignment. And the X label axis, this is going to be my horizontal axis, and this is going to be my hours worked. And then I need to tell it the range. So this is where it gets a bit tricky. I can copy these results over, but I need to have a comma in between the values, so I'm going to have to go in here and just manually put in that comma in between each of the values so that it will recognize where one value starts and the other stops. So I'm just going to put these commas here really quick, and I'm just referencing back to the other sheet while I do it. Okay, so what I'm going to do is just go ahead and delete these last 2 values, so my chart will look a little different from yours. I don't want it to be exactly the same because you do need to do this homework yourself. And then I need to tell it how many groups I would like to have. I used 4 when I divided mine. That kind of seems to make sense. We don't have that wider range of data. But I could also have it do 6 groups or have it do 5 groups. There's not really a right or wrong answer here, but because it kind of grouped nicely into groups of 10, I went with 4. And remember, mine looks a little different because I deleted those last 2 values. So here's a histogram. This is a perfectly viable solution to do it this way if it's not working for you in Excel. So then we need to export this. We can click on this button to export the file. We could also use the print screen to take a screenshot, or use the snipping tool to just take the snippet of this page out. I'm going to go ahead and just download this as a JPEG, and then I can just insert that into my Word document when I get back there. So now let me go ahead and run the ANOVA analysis. My data is set up with each group having its own column. This is how Excel likes to have the data to run the ANOVA, and so I've just oriented it this way to make it a bit easier. So I'm going to come up here to the Data Analysis Tool Pack and choose ANOVA Single Factor. And I need to select my data. I'll just select this all as one block of text. And what I'm going to do is just not select that last row, so my results will be a bit different. And my data is grouped by columns, and I did select my labels. And let me just check that output range to make sure it's somewhere I want it to go. So I'm going to click here, and that all looks good, so I'm going to click OK. And remember, my results will be a bit different from yours, but now I have my ANOVA results. Okay, so now we have all the information we need to go ahead and answer most of the homework problems. So let's go back to exercise 33. And the first question we want to know is, do the data meet the criteria for homogeneity of variance? So let's look at the variance of the three groups and just see what we think about that. And you know what, maybe I can get this to show up a little bit better. Maybe we can get these close to on the same screen so we can look kind of at the same time here. Let's go back to the descriptive statistics. Oh, I almost got all of them. So if we're looking for the variance, we're going to look across the three groups at the variance, which will be this row. Remember, my results are a bit different because I didn't select the last variable. And just what do you think about that variance? Go ahead and give the variance for each of them. And what do you think? Is it pretty similar? Is it really different? So do you think it's meeting that criteria? If you're using SPSS, you can do the Levin's test for equality of variance and report the p-value for that. But another way, if you're using Excel, is just to look at the variance manually and compare it. Okay, so number 2 wanted us to draw the frequency distribution of the dependent variable hours worked and wanted to know what the shape of the distribution is. So we need to put that frequency distribution in here. So I'm going to go ahead and go back to it. I'm just opening the chart that I just made, and I could just insert it, but I'll just go ahead and copy it and paste it into here. And then I need to know what's the shape of the distribution. So I can look at this manually, or I could also, well, I guess I'd have to run descriptives on them all together because we did it separately if we wanted to look at the overall shape of the distribution. So just give me a little bit of interpretation based on what the shape of this looks like. Do you think it's skewed to the left or skewed to the right, based on what the distribution looks like to you? And then if you're using SPSS, you can give the Shapiro-Wilk test of normality for the dependent variable. Otherwise, go ahead and look at your descriptive statistics and just look at the skewness and kurtosis. And that kurtosis is pretty significant for group 1, but remember I didn't select all of my information, and so it may be different for you. So just look across these for skewness and kurtosis, and based on our rule of thumb of more than 2 or less than -2, what do you think about the shape of that distribution? Number 3 wants to know what's the mean for the three groups hours worked on a job. So we're going to come up here to mean and just report those 3 means. And number 4 wants to know what are the F value and the group and error degrees of freedom for this set of data. So let's go over to our ANOVA tab, and we're going to find this information here. Remember, my results will be a bit different, but here's where your F value is going to be. So go ahead and look at that F value and report it on under number 4. And then the group and error degrees of freedom. These are just other names for the between groups and within groups. So here's my between groups and within groups degrees of freedom. I could figure that out manually with the formula that we talked about for exercise 18, but it's just reported here for me, so I don't need to do that. Remember, mine are a bit different, but this is where you would find it in your table. And let's look at number 5. Is this F value significant at alpha equals 0.05? So to answer this question, I'm going to come look at the p-value for my result, and I'm going to compare that value to 0.05. And what I will say here is either yes or no, it is significant because the p-value is greater than or less than the level of significance. So this part's important. You need to tell me what you're basing your decision on. And it's really just 1 or 2 sentences. It either is or isn't significant, and that is based on the comparison of the p-value to the significance level. Number 6, if using SPSS, what is the exact likelihood of obtaining an F value at least as extreme as or as close to the one that was actually observed, assuming the null hypothesis is true? This is just asking about the p-value, so go ahead and report that p-value here, because the p-value tells us the likelihood of obtaining the value as extreme as what we have if there was no difference between the groups. Number 7, which group worked the most weekly job hours post-treatment? So let's go ahead and go back to the means. And so I'm going to look at these means and I'm going to compare those and find which group had the highest mean for weekly jobs post-treatment. Remember, my answers are different than yours will be. So give a rationale. So just, you compared the means and that group had the highest mean. That's what we're looking for there. Number 8, write your interpretation of the results as you would in an APA formatted journal. So what we're going to say is what we did and what we found. So you performed a one-way ANOVA on the post-treatment weekly hours, and was this significant or not? And then give your shorthand results, which would be that F, comma, degrees of freedom equals what the F value is, comma, P value equals, and then what the P value is. We have this shorthand notation in the lecture slides, so review that if you need a reference for how to report those results. Okay, I went ahead and pulled up this slide from the lecture slides. I didn't want you to be confused about how to write the shorthand. So we would write F, comma, our 2 degrees of freedom in parentheses equals what our F value is, comma, P is equal to whatever our P value is. So just plug your results into this format. And then what is this telling you? Is there a significant finding here? So put this into words that people reading your article would understand whether there was a difference between those groups or not. What did you find? Number 9, is there a difference in your final interpretation when comparing the results of the LSD post hoc test versus the Tukey HSD test? So these are talking about the post hoc tests that were done. So when you look at the results of those 2 tests, and those were reported in the chapter write-up, was there a difference between the 2, or were they consistent in their results? And the reason we do post hoc analysis is usually because we didn't find a difference and we were looking for a difference, and then we're trying to explain why there wasn't a difference. But what we really should do is do a power analysis before we do our study, and that power analysis is going to tell us what sample size we need in order to find a difference. So we can prevent a lot of problems if we look before we do our test at what our sample size needs to be and set up our parameters properly before we conduct the test. So did they do that in this article? Did they do a power analysis beforehand, or did they not consider that until afterwards, and then they ran the post hoc test to try to explain their results? Lastly, number 10. If the researcher decided to combine the 2 treatment as usual groups to represent an overall control group, then there would be 2 groups to compare, supported employment versus control. What would be the appropriate statistic to address the differences in hours worked between the 2 groups? So this question again is getting you to think about the difference between a t-test and an ANOVA. So think about this. If you just had the 2 groups, what would be the appropriate test to do on that data? And if you did an ANOVA instead of the independent sample t-test, would those give you the same conclusion and the same p-value? What do you think about that? So what's the difference between the 2 tests, and could we do a different test like the t-test if we just had the 2 groups? So give me a few sentences on analysis here of what those results might look like if we did it, if t-test instead, or should we still do an ANOVA, or what do you think about that? All right, so that's what we need to do for exercise 33. And remember, once you run the stuff in Excel, you can just copy and paste these charts in. It's going to be a lot easier if you just run all of the tests and then come back and answer the questions instead of trying to do them one at a time.